Okay, so at this time, I'm going to teach you how to solve manually the mean, the median, and the mode of ungrouped data. If we say ungrouped data, we are referring to data that are not arranged in an interval or categories or in a group. Okay, so ungrouped data are data that are treated individually. Okay, these are data that can be treated individually. Okay, for example, we have the set of data that are given here are 34, 23, 12, 45, 37, and 50. We have here the formulas for the average or the mean, the sample mean, and the other one is the population mean. But we focus on the sample mean. Okay, the sample mean can be computed as x bar is equal to the summation of x sub I, where I ranges from 1 to n, all over n. Your n here and n in the upper limit of your summation notation are the same. Okay? They denote the number of sample or data in the set. Okay? So using the formula, we have x bar is equal to the summation of x sub I, where I ranges from 1 to 6. Why 6? Because there are 6 here. We have 1, 2, 3, 4, 5, and 6 all over n. But your n should be equal to 6. Okay? So in here, the summation of x sub I, wherein I ranges from 1 to 6, means that we have to get the sum of all the values of x's that are assigned to each one of them and divide it by the number of all the number of x's that are present, okay, which is 6. So we assign 34 to x sub 1, 23 to x sub 2, 12 to x sub 3, 45 to x sub 4, 37 to x sub 5, and 50 to x sub 6, all over n. Okay? So by substitution, we have 34 plus 23 plus 12 plus 45 here plus 37 plus 50 over 6. Okay? And the sum of this data is 201, and we divide it by 6, and we get 33.5 as our sample mean of this ungrouped data. Okay? Next, the median. The median is represented by capital MD or X with a bar curve above it. Okay? And we have the data set for the median to be used is the same set that we have used in our mean: 34, 23, 14, 45, 37, and 50. And in the finding of median, we have to consider two things: the number of data set provided. If the number of data set given is even, and if the number of data set given is odd. Okay? First case is the number of data set is even. N is even. So we have a number divisible by 2 is even. So we have 2, 4, 6, 8, 10, etc. Or multiples of 2 are all even numbers. In this case, we have 6 only. We have 2, 4, 6. There are only 6 number of measurements or data here. But before we get the median, we have to arrange them from highest to lowest. Arrange these scores or measurements or data from highest to lowest and determine the values that are found at the center. At the center. If I say values, there must be at, more than one. There must be more than one. Okay, but in this case, we only consider two values. Okay, so we get 37 and 34. Okay, the sum of this divided by 2. So we have 71 over 2 is equal to 35.5. 35.5. So the median value of this set of data, wherein there are only 6 of them, is 35.5. On the other hand, when the number of data or measurements is odd, we have 34, 23, 12, 45, and 37. This is 37. Okay? 34, 23, 12, 45, and 37. So again, we arrange them from highest to lowest so that we can easily determine the number or the values at the center of the distribution. So we have 45, 37, 34, 23, and 12. So we have the center is 34. The middle value is 34. So we call that as the median value. And finally, we have the mode. The mode is the measurement or the data having the highest number of frequency, or it is the measurement with the most popular. Okay, it is the most popular measurement. Okay, so looking at the data here or the measurements, we have 70, 71, 72, 75. There are two 70s, there are two 71s, there are two 72s, and there are three 72s, and there are two 75. Since 72 has 3 frequency, then we can say that the mode of this set of data is 72 because it has the highest number of frequency. All of those values belong to the measures of central tendency, and they describe the centrality of the distribution. Okay?